Okay, this is a slightly extended video from my short of whether or not a dimmer will still dim a bulb if you hook it on the neutral. Let's take a look. All right, I turn it on and we have 117 volts and a fully lit bulb. If I dim it to 75 volts, and it does indeed dim and turns the circuit off and on. Now there's a safety hazard here because when you do this, the bulb's still hot. We still have power even though it looks like it's off because the dimmer has broken the circuit. So you can't put a dimmer on the neutral to be code, but let's talk about why it still works. All right, it works for two reasons. First, it's AC. So the circuit goes both ways. So any type of switching for functionality purposes, it doesn't matter what side it's on because it's going to make or break the circuit going both ways. I know we think and talk like it's a supply and a return, but it's back and forth. So that's step one. Step two is, why do we call a sine wave 120 volts? If this is 0, what are the peaks? The peaks are actually 170. And there's a math formula that turns this sine wave into a value called RMS. See, our voltages are displayed in RMS. You'll see that on most good meters. So to take the sine wave and convert it to an RMS voltage, you're taking it and turning it into the DC equivalent of that varying AC voltage, which will tell you the ability for that wave to do work. So that might give you the idea that what a dimmer does is it converts this wave to this. But because it's AC, to go from this to this, you need more like a transformer because you have to affect both the neutral and the hot. And but we want to put our switching only on one wire. So to lower the overall RMS value, but only being connected to half the circuit, the dimmer does something really cool. There's a part in there called the triac. And what the triac does is as the sine wave is going to rise up, it actually delays when the circuit is completed. So the dimmer is really turning the circuit off and on at different times during the sine wave, which in fact will remove chunks of the sine wave and will lower the overall RMS value just by making and breaking the circuit and not actually have to changing the incoming voltage just by removing chunks of the incoming voltage, lowering the ability for it to actually do work without lowering the peak voltages. So if you put a dimmer on a scope, the sine wave will actually look like this. And this would be very dimmed, and this would be less dimmed. So I guess you could say it did lower the peak because if it delays so long that it doesn't turn on until after the peak, it lowered the peak. But I was more saying it doesn't just lower this peak, it just removes chunks. And because for this half of the sine wave, or this half of the cycle, the circuit is not complete, then it can only do work from here over. It can't do the same amount of work. So you get less watts, less light, a dimmer bulb by turning off and on at different times during the sine wave. It's really cool. Electronic guys are super smart. And it's funny because I was going to try to explain how the triac works, and I've watched a bunch of videos on how triac works, so I kind of think I get it, but every time I try to explain it, it's just, like I said, electronics guys are like magicians to me. I'm just an electrician. But even though I have this, I'm still an electrician. I leave that up there. At one point I had that up there just because I had some temp wiring going on when I built this room. And now so many people comment on it, I think I just might leave it. But all right, thank you very much.